Hello everyone. Today we are going to do predicted paper for chemistry GCSE, and basically this is going to be a revision for 2026 paper. Um, let's start with question 1. So uh, basically question 1 is about different substance and their structure. It says draw one line from each statement to the diagram which shows the structure. Okay. So the substance is gas. So it matches with the first diagram, which shows particles that are far apart and they are randomly arranged, which is a characteristic of gas, right? We know in solid particles are like close, like this, close to each other. That's why we have like solids have rigid shape, but in um, liquid particles they have gap in between, but in case of gas they are really far from each other, and here you can see that, right? The substance is a liquid. It will match with the one two three. Okay, let me just go down. uh, it will match with this one because as you can see, there is they are close but not as close as solid. Like in solid, there is no almost no gap between particles. There is a gap between particle, but it's not that much, right? So um, basically in liquid the particles are close, but um, they are not as close as in case of solid. Then the next substance is ionic. So this will match with this ionic here, because here you can see there is a positive and negative sign, right? So this matches with the third one. This is a lattice of large and small cubes. Um, uh, Ionic means it has charges. It can be positive and negative charge. Next one is the substance is solid metal. So this will match with this because the lattice of the circle with a smaller circle in between, this is the solid metal. Okay, which shows a fixed lattice of positive ions, and yeah, this is solid. So next one, it shows the structure of an element, and we have a question: what is the name of the element? So for this structure we need to tell if this is carbon, chloride, nitrogen, what substance is this. So if you look at the structure, this is carbon. Basically the structure is hexagonal, right? This structure is called hexagonal, which is the characteristics of carbon, and each carbon atom is covalently bonded to three other atoms in the same place. Like if you notice here, three for each of them. So this is carbon, the answer for this. And why does this element conduct electricity? So we need to tell why carbon conduct electricity, because it has delocalized electrons. Because the like carbon, or which is in like, or graphite, it is good conductor of electricity because it has delocalized electrons. Delocalized electrons means free electrons. So because free electrons means they can move, right? And when charge move, it create electricity, it generate current, and that's how it can conduct electricity. Okay. Next one, we this is a figure 2 which is showing the structure of an alloy. The question is asking explain why this alloy is harder than pure metal. Why? Okay, so basically the alloy is harder because the differently sized atom disrupt the regular structure, and the regular layers, preventing them from sliding easily. So in pure metal, this is where is pure metal? Okay, this is metal Y. In pure metal, pure means what? Pure means all the atoms are of same size, all atoms. Okay, all atoms when they have same size and they are arranged in a regular or in ordered structure. This allow layers of atom to slide over one another easily when force is applied. Like if all atoms are same size like this, so they can slide over one another easily when we apply force. So which makes metal like relatively soft. Okay, but in case of alloys, uh, because there are two metal X and metal Y, they are of different size. Okay, they have different size and which disrupt the regular arrangement of the layer. You can see one is bigger, others are smaller. So the presence of these different sized atoms, it makes it much more difficult for the layers to um, slide past each other, and this increase resistance. So because of this, resistance increases, and which makes alloy stronger and harder than the pure metals. Pure metals are more malleable. Okay, they are malleable. Malleable means they are soft because of the same size atoms. Okay, let me just erase it. Hmm. So now we have next question. This is the structure of alloy, right? So in for the same structure, the question is asking what percent of the atom in the alloys are atom X. Okay, so we need to figure out this is metal X, right? You can see there are two metal X. Okay, so and if you count all of them, they are total 25. So 2 plus 25, there are total 27 atoms of metal X and metal Y. And to find the percentage of X, what we need to do, metal X is 2 out of 27. Okay, and to convert any fraction into percentage, we times it with 100. And if we just do the calculation, this is 200. 2 times 100 is 200 over 27%. So if we divide it 27 over 200 divided by 27, that would be 7.4 something percent. So this much percent is their atomics in alloy. Okay, next is what type of substance is an alloy? Take one: compound, element, or mixture. So alloy is mixture because it is a substance which is made by melding two or more elements together. When two or more elements are mixed together, at least one of them is a metal. So they are physically combined and not chemically bonded, which means it is a mixture. Mixture means they are not, they are just physically combined. Okay, not chemically, not chemically. That's why it's mixture. Okay. Um, okay. We have next question here. Okay, so a student investigated the reactivity of different metals. Okay, and this is the method used. So what the student does is place 1 gram of metal powder in test tube, add this metal sulfate, and then wait for 1 minute and observe, and then repeat using other metals and metal sulfates. So what is the dependent variable in the investigation? So basically The dependent variable is what you measure or observe in an experiment. That is called dependent variable. So in this investigation, the student is observing whether a reaction occur, um, and by like there is a tick or a cross you can see. So after mixing different metals and metal sulfates, so basically uh, that's why we can like take this one, because it is asking about reactivity. Reactivity means it is related to reaction, right? So that's the uh, I mean the correct one, because the other options are either independent, like time taken, type of metal, and volume of metal sulfates. Okay, the type of metal being tested or controlled variable, we can control time, we can control volume, right? Um, so yeah, that's it. So basically, now we have given observation that the student could make that shows there is a reaction between zinc and sulfate. Okay, so in this one, we need to check what is the observation. So the formation of, because it says like when zinc and copper sulfate, when they react, it forms a brown solid, um, which is copper metal or zinc metal disappearing. So when a more reactive metal, for example, like in this case, zinc is more reactive, is placed in a solution containing ions, or less reactive metal, for example, copper sulfate, there is a displacement reaction occurs. Okay, why? Because zinc would displace copper from the solution, and the copper would produce brown solid, which we can observe. So yeah, next question. So the student used measuring instrument to measure different some of the variable. Draw a line from each variable to the measuring instrument used to measure the variable. So variable is mass and volume of metal sulfate and powder. So mass, for measuring mass of metal powder, we use balance. Okay, and for volume, volume is measured by burette, um, or measuring cylinder. Okay, um, we can say measuring cylinder. um, yeah, next one is use the result shown in table 1 to place zinc, copper and magnesium in order of reactivity. Okay, so we need to place them in order, which one is more reactive, which one is less reactive, out of zinc, copper and magnesium. So magnesium, uh, we need to start with most reactive and then least reactive. Okay, so magnesium is more reactive than zinc, and zinc is more reactive than copper. So the last one is going to be copper. Okay, so it's magnesium, zinc, and then copper. Okay, suggest why the student should not use sodium in this investigation. So basically, sodium is too reactive and it will react vigorously, okay, with other substance, which could be dangerous. So it could be dangerous. Why? Because sodium is too reactive. Okay, it is a highly because its nature is um, like alkali metal. Okay, it is highly alkali metal, and it reacts violently with water and produce hydrogen gas, and which can lead to explosion also. Next is which metal is found in the earth as the metal itself. So it is gold like is very unreactive metal, which means it is found in the earth crust in its native metallic form rather than a compound. Okay, so it's gold. Next one, we need to balance this equation. Balancing means both side, reactant and product side, should be same. So how do we do? We count the number of atoms each element on both side. So if we have iron here, then we have oxygen and carbon. So if you check the left side, I mean the reactant side, iron is 2. You can see it's 2. Oxygen is 3 and carbon is 1. There is just one carbon, right? But on the product side, right side of this arrow, this side, we have 1, carbon is 1, oxygen is 2. Now to balance, because I want 2 iron this side, so if I multiply it by 2, I get this will become 2 also, right? So similarly, this is 3, this is 2. So if I multiply this by 2, this will become 6, and this by 3, this will become 6. So basically what I did, I multiplied first one with the second number and second one with the first number. This is same 1 1, but now let's put uh, it like if I put okay, if I put 2 here in the second one, just a minute, let me just erase it. Yeah, if I put 2 here, there I have 2 iron, but then this is oxygen is 6 there, right? So I multiplied this one, this side oxygen is 2, I multiplied it by 3, right? So this is balanced. Now this side I need to multiply with 2, because 3 times 2, if you notice, 3 times 2 is 6 and 3 times 2 is 6. Now they both are balanced. But now if you check iron again, because we multiply this with this, okay? So 2 times 2, 4. Now iron is 4. But this side iron is 1. And not 1, actually 2. So what I need to do is, I need to put here 4. Okay? Now let's check if everything is balanced. Now 2 iron is there. This side we have 4. This side we have 4. Now for oxygen, 3 times 2, 6. Here 3 times 2, 6. This is balanced. Now carbon is 3 this side and here, so we need to put, basically there we have 3 carbon, right? So I need to put here 3. Now it is balanced. Okay, this is the balanced equation. um, Balancing means we need to just count the atoms both side. Okay, okay, so in this question, in the above one, let me erase so you get this. Okay, for the above equation, it is asking name um, name the element used to reduce iron oxide. Okay, so the element is basically, let me just zoom it, the one which is reducing iron oxide. If you notice, this is iron oxide, right? And what is reducing iron oxide is carbon, because with carbon now you have oxygen here, right? Reducing means either adding hydrogen or removing oxygen. So now oxygen is with carbon, but here carbon was just by itself. Now it has oxygen. So carbon has taken its oxygen, right? So The element that reduce iron oxide is carbon. Okay. Hmm. What is meant by reduction? So what does mean by reduction is like reduction, these are the option. Reduction means loss of oxygen, or it also means addition of hydrogen. It also means removal of oxygen. For oxidation, it is opposite. Oxidation means gain of um, like oxidation means gain of oxygen or removal of hydrogen. Okay, so this one is the correct one. Loss of oxygen. Okay, I think this one was not needed. We need to do this one. Okay, fourth one, yeah.